Let us now talk about the media that are used to keep video information, either analog or digital format. Even though before this we say that VHS is analog, but certain videotape are used to keep digital video information. We call it DV or digital tape. Looks like this. It was the first storage to store video information digitally, and it is still in use. It was used in some digital video camera. So just now, a medium that is seemingly analog, which is magnetic tape, but used to keep digital video, there is another medium that is seemingly digital but used to keep analog video. That is laserdisc. Sounds like digital media, but LD or laserdisc is keeping digital video as analog. So the format is either NTSC, SECOM, or PAL. And this is how it looks like. And comparing to DVD or CD, this is the size of LD. It's really bulky. Being bulky in size, LD has almost been phased out completely, while DV tape is still in use due to its robustness and small in size. Next is compact disc. This is the logo. Video stored in CD or compact disc is called video CD, VCD, mostly MPEG-1, but there is one format of VCD which is called SVCD or Super VCD. The format is MPEG-2. Average movie length would require 2 CDs to store entire movie long because CD is quite limited in size. So the data size for CD is around 650 to 700 megabytes. It's not even gigabytes. And read-write ability. There are compact discs that we call CD-ROM. This one is factory writable. We can only read it. CD-R is one-time writable. CD-RW is the CD that we can erase and rewrite again. The read-write head uses infrared laser, the laser that cannot be seen. It is not written in this slide, but the shape of track in compact disc is spiral, like this. Next, after compact disc is DVD. This is the logo. And as opposed to common misunderstanding, DVD stands for digital versatile disc. It is not digital video disc. It is the first optical medium that is big enough to contain entire movie with multiple soundtracks, menu, subtitle, and many more features that you can find in DVD video. The size is ranging from 1.5 to 17 gigabyte, but most common are 4.7 gigabyte for single layer SL and 8.5 gigabyte for dual layer. The read-write ability is almost similar to CD. DVD-ROM is the one that's factory writable only. DVD-R is one-time writable. The plus minus over here just indicate the difference in material that they use to manufacture the DVD. DVD-RW is erasable and rewritable, and there is another kind of DVD, we call it DVD-RAM, that is erasable and rewritable just like hard disk, but the media is concentric like this instead of spiral. DVD-RAM is the only optical media that is concentric in nature. All other optical media, LD, CD, and the other format of DVD and also Blu-ray disc afterward, they are all spiral. DVD RAM is the only one that is concentric, just like hard disk. And other optical media are spiral. And this is how DVD RAM looks like. It has a casing, and then there is a place where we can open up to get the disc out. And instead of infrared laser, DVD is read and write using red laser. Next is BD or Blu-ray disc. This is the logo, and this is the logo for Blu-ray 3D. It is the first optical medium that is big enough to contain the entire 3D movie or HD movie. It is high density, at least 4 times the capacity of DVD, because BD or Blu-ray disc, as the name suggests, is using blue laser in read and write, whose wavelength is half of the wavelength of red laser. The way we keep data on two-dimensional media is double in 2 dimensions, either X or Y. So in total, it is quadruple in terms of capacity increase. The size is either 25 gigabyte for single layer or 50 gigabyte for dual layer. Read-write ability similar to CD and DVD. BD is factory writable. BDR one time. BDRE is the BD that is recordable and erasable. The read-write head again uses blue laser. Comparison between the wavelength of laser and the track size of the 3 kind of optical media just now. There's a first one, HD DVD. The first one, CD, is using infrared laser 780 nanometer, DVD red 650 nanometer, HD and Blu-ray blue laser 105 nanometer. The largest track size is CD, DVD is half of it, and HD DVD not really half of DVD, but Blu-ray is less than half of DVD. So as you can see, when one direction of the dimension is half, the total capacity is actually becoming quadruple. Next, let us talk about the standard video aspect ratio. Video aspect ratio's standardization has to be done so that the display manufacturer and movie producer can match their production size, so that the viewer can enjoy watching video in the full size of their TV or display. So there are many display aspect ratio here. The smallest one at the top is the TV aspect ratio. Before the invention of LCD or LED television, this is the best display size that we can have, because TV used to be built with CRT, the cathode ray tube. Because inside the tube it is vacuum, it has to withstand the atmospheric pressure, and if it is manufactured too flat like this, for example, the glass that used to build the tube will not be able to withstand the atmospheric pressure, so it will crack. For that reason, TV, before the invention of LCD TV or display, has only one aspect ratio. TV can only have one ratio because of that, but in cinema, we can still watch widescreen movie. When we have technology to manufacture LCD TV, we start to manufacture widescreen TV so that we can watch widescreen movie at home properly. And this is it. The TV aspect ratio is 4 to 3 or 1.33 to 1. This is also called full screen resolution. And then there comes high definition TV, HD TV, the TV that is built using LCD or liquid crystal display or LED TV. The ratio is 16 to 9 or 1.78 to 1. And then the newer display screen will have a wider ratio. Widescreen ratio is 1.85 to 1. And the largest widescreen ratio is the anamorphic widescreen ratio. Before 1970, it was 2.35 to 1. This is not for TV. It is for cinema. They call it CinemaScope ratio or Panavision. And currently, it is 2.39 to 1 ratio. The actual movie ratio in the cinema. So, because there are so many video display aspect ratio, there can be mismatch in the size. If the video aspect ratio and the display aspect ratio are not the same, then there will be a mapping scheme to match the sizes so that the viewer gets the best viewing setting of his choice. This is either fitting a wider video into the narrower one or fitting the narrower video into a wider display. First is fitting the wider into the narrower. For example, we have HD TV. We want to fit into full screen TV like this. The first technique is letterbox technique. The entire width of the wider format, which is HD TV, is fit into the full screen TV. So we match the width. This will leave some part at the top area and bottom to become black. Some people think that this part is actually hiding some part of the movie, but actually it's not. It's actually the part of the display that cannot produce the movie scene. Many of them think watching HD TV with full screen like this will show more information of the video, but they are wrong, because if we fit it like this, that is, we fit the height instead of the width, we call it pan and scan technique. We match the height. Now, instead of having that black area on top and bottom, now part of the movie will be cut off. So it's up to you. If you think having this black area at top and bottom is distracting, you can watch widescreen movie in regular full screen TV in full, but then you will be missing the left and right part of the movie. Next is to fit the narrow movie into wider display. For example, you have at home a widescreen TV, you have a VCD of regular full screen TV. The first technique is pillars technique. It's like letterbox, but now we match the height. So now the black area is on the right and left. And similar to pan and scan technique, we can also match the width, but now the top and bottom part of the movie will not be visible. And of course, if we don't want to keep the aspect ratio, we can perform stretch fitting, distorted. If we have a narrow movie we want to display in widescreen TV, we can stretch it horizontally. So now the objects in the movie will be distorted horizontally. And if we have a regular full screen TV and we want to watch widescreen video, we stretch it vertically. Now the objects in the movie will look distorted vertically.